When space-time is considered to be homogeneous and isotropic, it becomes impossible to define whether the light is coming from the celestial dome or going back in time and in that direction of the past. We will try to visualize this in the diagrams that follow. The real movement of time is always in the direction of our future. The virtual flattening of the future light cone events would place the ground zero atom in the position of the observer in the present, since he would be occupying the vertex that joins the cone of the future with the cone of the past. Note that the space would always be outside these cones and the vertex that joins them. When the apparent movement of light is already in the direction of our past, gravity appears as being a force of positive orientation, being confused with the acceleration of movement. Thus, before the inversion in the direction of its arrow, time should have taken a negative orientation, just as it would happen in an implosion. The movement of light, if it existed in the future, would have to be retarded. It is seen that we could only trace the light of a star in the direction of our past, and not that of our future. The acceleration could only be attested after the arrival of the star's light on Earth, or after its scattering. It is when the star can be spotted instantly, but, in some cases, with the appearance it had millions of years ago. At this very moment, the light would no longer depend on the direction of its propagation, making the space isotropic. As what is in the future cannot be measured directly, because it has not yet happened, science has decided to conclude that light, necessarily, would have to be coming from our past, or from the sky, over our heads. With this, we eliminate the real possibility that light, by amending its wavelengths, could be contracting in the past, and not stretching in real time. As in an isotropic space, the two alternatives would be possible. We could say that, when it comes to our point of view, the contraction of the space would be exposing its previous expansion. This would explain why the expansion of the universe would come out of its own time. Likewise, the negative stretching of space, in the future, expressed in its continuous curvature, suggests that time would be virtually contained in the observer himself, by a principle of exclusion of access. In relation to the Doppler effect, it would depend on this double orientation of light and its polarization to define the respective approach or removal of a galaxy through ultraviolet or infrared. Thus, as the contraction of time seems to accompany this movement of light stretching, the Doppler would serve only to attest that the universe was stationary in its origin. That is, despite their apparent and relative movement, galaxies would not abandon their original positions in space. Let's consider the example of Beta Andromeda and an observer looking at the star from Earth. This observer sees the star instantly, but with the appearance of 75 years ago. If the star were to go out now, he would see it shine in the night sky for the next 75 years. This suggests that the observer needs the constant presence of light to see the star, regardless of its previous displacement through the vacuum. Ground zero, the beginning of time counting, would now be in the observer's position, and not in Beta Andromeda's. It is known that the arrow of time always points to our future due to the problem of entropy. When the 0 point of time is placed in the observer's position, the future is confused with the present. It is as if the observer goes back in time and in the direction of his past, so that he can see the star shine in the night sky instantly. In this movement of retreat, the arrow of time would undergo an apparent inversion in its direction, as if pointing to the past. This problem would be a consequence of the isotropic behavior of light, without which the star could not be seen. When the observer can see the star, the light which it would have emitted into space would have already reached him on Earth. The observer's memory, for needing the constant presence of information, would be subjected to a principle of exclusion from access to what would be in the future, or within the live cone of the event. This would have nothing to do with the physical reality of the universe. Exclusion would be restricted to the observer's point of view. As he sees the star's present light, albeit instantly, this suggests that the merger between his future and his present would be a consequence of the migration from the 0 point of time to his position. Time becomes relative. Then, there would be two distinct directions for the same arrow of time, coexisting harmoniously. 1. The real arrow points to the future. 2. The apparent arrow points to the past. These two orientations of time become inseparable, as both depend on a single messenger, the light, synthesizing all other forms of electromagnetic radiation. Thus, when we replace space with its messenger and use the speed of light to measure time and astronomical distances, space-time becomes isotropic. Considering that the real movement of time is always towards our future, hypothesis 1, and the future has not yet happened, it is said that this movement would be negative, because it would retain light, time and information. After the light emitted by Beta Andromeda left its future light cone, which would coincide with the entrance of the Earth in the space of that cone, the future would pass over the ephemerality of the present, and become past. This apparent inversion of the arrow of time tells us that the past would be contained within ourselves as an intrinsic movement. If it weren't for our memory, we wouldn't be able to grasp the reality around us. The onus of using it is that events could not be evaluated in real time. Before, they need to be compared to the patterns stored in our brain. Something out there exists only if it can be remembered. When we don't take these concepts seriously, we run the risk of assuming that starlight is coming from our past, not from our future. Isotropy itself, or the reversibility properties of light, the messenger of space, would condemn this attitude. It cannot be said whether the wavelengths of light, which would connect us to a distant star, would be stretching or contracting at a given moment. The separation by the blue or red color would be the result of the contraction of time at subliminal levels, with the space tending to its two original dimensions and to its stationary state. The polarization of light leads us to a circular and uniform movement, in which there would be no real separation between the extremes of maximum and minimum energy of light. This would be a consequence of the future light cone concept, as it would result from the superposition of light waves in the time that separates them from each other. This type of cone is straight and has a perfect circle at its base. The light waves would be similar to the ones you see when you throw a rock on the surface of a lake. It is normal behavior for the scientific community to treat the future as an inverse image of our past. This stems from the belief, rooted in classical wave theory, that light waves would be continuous. However, a cosmic radiation will only be considered as being in the background after the apparent inversion of the arrow of time in our present. As you can see, this problem is inherent in the observer's point of view, as he seems to contain time as a negative movement.